Okay, guys, welcome back. Welcome back to the next session of Days Cohort by Fluxus. So today's agenda is we will be discussing some problems on linked list. Okay, yesterday we discussed the basics of linked list, circular linked list, and doubly linked lists. We understood how to create a node. Okay, okay, how to create a node. Okay, that's we saw that we can create it using a class. Then we saw how to use oops principles to uh, create to again come forward with our discussion. Okay, so now many of you are still joining. Okay, so today we will be discussing some problems on linked list. So let us start our discussion now. So the first problem in our hand is, okay, suppose yesterday we discussed how do we uh, insert nodes. Okay, that were the basics. And secondly, we also discussed how to delete nodes. Okay, from a linked list. Today we will be discussing today we will be discussing one problem that deals with deleting the entire linked list. Deleting the entire linked list. How are we supposed to do this? Okay, uh, what should be our algorithm for this? So why is there a need to delete an entire linked list? First of all, suppose you are dealing with some problem, or say you are working with some scheduler algorithms or something like that. You need to schedule some data, okay, for some purpose, and now you have created a linked list of that data to be fed into another system. So the requirement of data will get exhausted after a while. Okay, and you need to uh, you need to free your physical memory, say. So you will need to have to delete the entire linked list, entire data. So as I said, linked list supports storing data in linear fashion and in a non-contiguous way. So it seems feasible that the data that is stored in the physical or the secondary memory in our case will be a linked list. Okay, so that's where this concept of deleting the entire linked list can come into picture. Okay, so what's the algorithm that we are supposed to apply here? Let's see. Uh, let's say if I needed to delete a single node, suppose this was a node, this was my linked list initially. Okay, this was being pointed to by the head. So suppose I needed to delete this one. I needed to delete the second linked list. Second link? What did I do? What did I do previously? I did was I just changed the links. What I did was I made the next of the first node point to the second node, and while doing that, what was happening was this link got deleted. I deleted these two links. So what was the final current structure? Now what's the structure of my linked list? It was something like this. Head was pointing to the first node. Okay, okay, first was pointing to the third node. Okay, and third was pointing to null, and the second was in an isolated manner. Second was in the isolated manner. So let's suppose if I want to delete the entire linked list, what I can do, I can just repeat this funda only of deleting one single node to the entire linked list. And after isolating the node, what I need to do is I'll start with the first node, isolate it, then move forward with the second node, isolate it, move forward with the third node and isolate it. And after each step, after the node has been isolated, this is a node that I need to delete. What I can do is I can use one function named as free. What is free used for? Free is used for garbage collection. In Java, garbage collection happens by default. Okay, in C++ we need to use free. Okay, so what we will do is we will just pass, say, free node 2. So what will happen is whatever memory that was assigned to this node 2 will be released released to the memory pool again. So this is what we have to do. We first have to iterate towards to the end of the linked list. Pick one node at a time. Pick one node at a time. Change links to isolate it. Change link to isolated. After isolation, what we will do is we will just free the memory. occupied by that node. Okay, and this entire process, if we reach the last node, what will happen? The entire linked list will get deleted. This is only what we need to do here. Okay, so let's start with the coding part of it. Any doubts in the explanation? What we need to do? We just need to do these steps only. We will first iterate to the end of the node. We will pick one node at a time. We'll try to change the links and isolate it. Then we will free the memory. And if so, please be flexible the head and tail part once again. See, the head is a pointer that points to the first node of the linked list. Okay, and there is no tail in linked list. Okay, Shahars. Shahars is asking what is head and tail. So there is no tail in linked list, but what is head? Head is a pointer that points to the first node of the linked list. So whatever node the head is pointing, we consider it as the first node of the linked list. Okay. Now, any doubts in this process? We will have to iterate to the end of the linked list, pick one node at a time, isolate it by changing the links. And how will we change the links? We'll just make the first node point to the next of the second node. Okay, and then remove the links of this particular node. After this, what we will do after the node has been isolated, we will just free its node. Okay, no, head is a pointer. Head can also be the node. Okay, Shahars. You can also name the first node as head, or you can just create a node and make a pointer point to it. Both are considered okay. Okay, so let's move on with coding of this thing, coding of this particular flow. Okay. Okay, so let me just start. So first what I will do is I'll just copy paste the previous code, okay? Because in this only we were iterating over the whole, so that I do not have to create the node again and again. So that's why I've copied the node and I'll make necessary changes to this code. Okay, so what is done here? First, I have created the node structure as discussed yesterday. We will be using one class, declaring its members as public. Create two things: one is the data member, another is the address member. So address is nothing but a pointer pointing to the next node. So this is how we declare a point address member. Next, this utility function is used to print the node. Okay, okay. Now this one is used to insert the data at the front, and this one was the main function which was used to uh, firstly was used to declare the linked list, then create new nodes of the linked list, and then initialize the linked list with different types of data. And this function was used yesterday to insert the data at the front. So I'll just make some necessary modifications in this particular code only. So first of all, what I need to do is I need to uh, declare one function to delete the list. Okay, there was one problem in this code. Okay, what was the problem? That I needed to return the head, okay, so as to have the same head here. Okay, so if anybody wants to avoid this thing, you have to play with variables or return values from the functions. What we can do instead is we can play with pointers. Okay, so because pointers help us to directly change the values at the address, so it will allow us to change values directly at the address. So we will not need to change return anything from the functions. Okay, and so that there are what will happen is the function calls, as we are reducing the returnable functions, what will happen, the function call time will return, okay, reduce, and directly the modifications will be done on the address, so our code will become faster. Okay, so in this function what I will do is I'll just create one function that will not return anything. So let me create it. I will call void delete linked list. Okay, what will it have is it will just get one reference. It will get the reference of the address of the head of the uh, linked list. So because head is in itself a pointer, so I am passing the pointer's address to the linked list. See, look here, what I am doing here. First of all, see, uh, I think it can get confusing for most of you. There is a variable, there is a variable, say int type, named as a, storing the value 26. It is stored at an address, say a2cc. Okay, a2cc, this is the address of a. Okay, what I did now was I created a b pointer to store the address of a. Okay, so what b is storing is, b is storing the address of a. Okay, but b is itself occupying some memory on the physical memory. So suppose b is stored at b2 b3dd memory. This is the address of the pointer, this is the address of variable, this is the address of pointer. Okay, now what I can do next is I can again create another pointer. Okay, as it is a pointer to a pointer, what will happen is, one pointer is for one asterisk is for one pointer to the variable, two asterisks are it is a pointer to what, to another pointer. Say I created one another pointer to point to the sorry, to point to the address of b. So what will it store? It will store the address of b, and it will also be occupying some space. Let's suppose it is occupying this space. Okay, so this will be the address of second pointer. This will be the address of second pointer pointing to the d. So what is happening here is, uh, this is our node. This is our node. In our case, this is our node. Node is a int data function. What is our head doing is, head is in itself a pointer. It is storing the address of our node. Okay. Now what I will do is, I'll pass the address of node. I will pass the address of head to the our functions. So what will happen is, any modifications done here will will change the value at the address. So at the address, what is stored at the address, the head is stored. So any modifications done here will change the value at this particular location, which is nothing but head. So what will happen is, we are directly changing values at the address level. So we need not pass or return anything out from the function. So this is what I will do. Okay, so this is what we will do. I will create another pointer to the head and make changes to directly to the address of the head, so that I do not need to return anything back from the uh, functions. Okay, shares head is a no. Acha, I think I have explained this one. I read the comment now. Okay, so this is what I will do. Okay, so what is happening, to pass any address, what we do is, we use this operator, and operator. To reference the address, we use the asterisk operator. Okay, like what we do is, b is storing the address of a, so we write it something like this. This is known as dereference operator, reference operator, and this is known as dereference operator. This one is known as dereference operator, this is known as reference operator. Okay, so this we will use this funda while coding the functions now, or in the further lectures too. Okay, because we do not want to make return anything to make our functions complicated, function calls complicated. What we need to do is, we will directly make changes to the uh, main function itself. So what it will receive is, it will receive the double asterisk head. So what it will be receiving is, it will be receiving the address of head. So what is it receiving is, it is just receiving the address of head. Why? So as to make changes directly to the address, and we do not need to pass anything out from the function. So now what we will do is, we will first make one temporary variable to store the current node. So what I will do is, I will make one temporary uh, temporary node to store the value of the node. So what it will store is, it will currently store the current linked list. Okay, so what will temp referring to? Temp is nothing. Temp is just referring to the value that is pointed to by the head. So what I am making is I am just making temp also point to uh, the same linked list. So for this case, what is happening is, for this particular case, what is happening is, uh, this is our linked list. Okay, head is currently pointing to the first node. What I am doing is I am creating one other pointer, that is temp, and making it point to the address pointed to by head. So what is temp pointing to now? Temp is also pointing to the first node of the linked list. Okay, now what I will do is I'll just make okay, other change, that will be node connect another pointer. What I'm creating here is I am creating another pointer here and making it as null. Okay, now actual gameplay starts from here. So what I will do is uh, I'll traverse the whole linked list, and while traversing the whole linked list, what was I doing is I was just checking until I will traverse until and unless the node does not starts does not becomes a null node. Okay, this thing only I will do here, but in our case the node is represented to by the temp. So I'll iterate until and unless the temp becomes equals to null. That is, I am at a particular node that is not pointing to anything. That is a blank node. Okay. Now what I will do is I'll just make key okay, the new next is temp ka next. What I am doing is I am making next point to the node pointed to by temp. What I am doing here is, this is, for this case this is our temp. Okay, what is temp ka next? Temp, this is temp ka next, this node is temp ka next. So what I am doing is I am making next point to temp ka next. So what indirectly I am doing is, what I am doing is ki temp is now pointing to the first node and next is now pointing to the second node. This is only I am doing, this thing only I have done. Temp is storing the value of head, it is pointing to the first node, and next is now pointing to temp ka next. So what is next pointing to? Next is now storing the value of the second node. Okay. Now what we will do here is we will just make to isolate the value. What we need to do to isolate this node? If I need to delete this node, what I will do? I'll just make a key, whatever the next is, make temp move here, make temp move here. So what will happen is temp will not point to this, temp will start pointing to this. So what will happen is, if temp is pointing to this, so what is, and if temp is our head, you consider temp as to be head. So what is our linked list now? The linked list is now this one, and this got isolated. Okay, so what we can do now is I can just delete this particular link and free this memory. So what I will do now is I'll just, after this operation, what I will do is I'll just make my temp equals to next. So what I did is I made first, what I did is I made temp to start pointing to the first node. Then what I made another pointer as next and made it point to the second node. Now what I did is I now made temp point to the second node. So at this particular stage, at this particular stage, what is happening is temp is now pointing to the second node. Temp is now pointing to the second node, and the first node is free to be uh, deleted. Temp node is free to be deleted. So what I will do here is, I'll do just a simple thing. After this step, what I will do is, as the first node is free to be deleted, what I will do is I'll just free the memory occupied by the first node. So what I will be doing is I'm just deleting the node that is deleting the memory that is occupied by the node pointed to by temp. Okay, and now I'm making temp to point to next. This is nothing, this is just a swapping. I'm just swapping the first value with the second value. Okay, any doubts still here? Okay. So let me move forward with our discussion. Now, at the end of this operation, what will happen? Every particular node will be deleted. Every particular node will be deleted because it will move till the end of the linked list. It will move till the end of the linked list. So what I need to do now is I need to make the head pointer as null, because head pointer, if the linked list is not there, what will happen to the head pointer? Head pointer will not store any value, will not point to any value. So what I need to do at this stage is I need to make the head as null. And as we are playing with pointers and addresses, what will happen is I need not return the current value of head. If I was using this particular thing like this, what I did yesterday, this particular implementation, what I needed to do here is I needed to return the head with whose current value is null. And in the main, what I needed to do, I need to store this new value of null, head. But as I am dealing with pointers here, what I can do directly is I can directly change the value stored at the address of head to be null, and everything works just fine. So this is how we delete the node. Okay, now let me just make some necessary changes in the entire code to make this code run. Okay, I'll do nothing. I'll just make some little bit changes here down here. Okay, just to make all the functions uh, directly directly tamper with the value at the address and not at anything different. Node next must be equal to the value at head. Okay, and value ka head must be equal to new node, and this line has no meaning now. This line has no meaning now. Okay. Let me put it in bracket so that operator precedence is taken care of. Okay. So let me just check this once more. Okay, node ka data, receiving the node ka data. Okay, nothing. No major changes here. Here, what I am getting, I am getting the node while node is not null. What I am doing, I am just printing the thing. Okay, no changes here, no changes here. Now I'll have to make some little bit changes in the main function. What all changes I will make is I'll just okay. Somebody was asking yesterday ki, how will I use this thing in the loop. Okay, so let me explain that also. What we will do here is, as I have already created one function that inserts nodes at the front of a linked list. So what I will do is I'll just create one empty linked list and use this function now to add new data in my linked list. So let's suppose what I will do is I'll just create node head equals to null, and I'll not create any other node. I'll not create any other node. What I will do instead is I'll use this particular function, insert front function, to make a newer linked list. So what I will do here is I'll just call insert front function. Okay, and what does insert front needs? Insert front needs the data to be inserted and the head, address of the head. So what I will pass here instead is, okay, what I will pass here is the data to be inserted. Let me insert 23 here, and what I will also pass it is the address of the head. And I have, as I have already told, I'll use the reference and dereference operators here. Uh, okay, and it stores the address of any variable. So as I am mentioned here at this particular location. So what we will do is we'll just pass 23 to be added to the linked list, which is currently, as head is currently pointing to null. This means the linked list is currently empty, and what I need to do is I just need to add the uh, values here. Okay, and what it will do is it will just create a new node for us. It will create the new node. It will assign the new the data that we are passing to the new node. It will make the new node next point to head, and then the head will be the new node. So ultimately, one linked list will be created. So let me use this particular operation multiple times to create one linked list first. Let me change the values. 65, 73, 55. Let me make it at 32, and this one has 59. Okay, so what will happen at the end of this operation, after every insert front, one linked list will be created. That will be 23, 65, 73, 55, 32, and 59. Okay, let me just use one let me just print the linked list at the start before inserting any new node, and then print linked list. Okay, this one is before inserts. Let me see what will happen if I try to print anything uh, before inserting anything. This one is after inserts. Okay. Now what I will do is I'll just remove this one because this has no meaning now. Okay. Now what will happen? I just need to okay. Let me just check whether my insert function is working on it. Then I'll do the next operation. That was deleting the linked list. Okay. So let me just run this particular code. Okay. So running this code, I need to first create the object. What was the name of this? Uh, okay. CPP minus 4. Let me make this as full screen. CPP minus O and then delete. No errors must. Okay, what is happening? Nation avoid print link list, word link list. Okay. Oh, sorry. I thought I made a silly mistake here. This is a function, so it just needs to return. I thought I am just using a print statement here. Sorry, my mistake. Okay. Oh, let me make some changes there. Uh, let this also get a string s. Okay. And at the end, what it will print as, it will print just, it will just print s first, and then it will start to print the overall things. So let me just make some changes here first. I'll just pass before inserts here, and I'll pass after inserts here as the second argument. Check, I think error might be removed. Sorry, it was my mistake. I thought I'm using a print statement, but that was my custom print. No problems. Then let me just run this. See, for inserts, what is happening? The linked list is empty, and after inserts, the linked list is getting created 59, 32, 55, 73, 65, and 23. So, what is happening here is I'm using utility function to insert one new data to the particular linked list. Okay. So, now what I will do is I need to delete this particular linked list. So what will happen is I need to delete the linked list. So which node I will use, which function I will use? I'll use this function delete ln, as I have already discussed the implementation of this. So now let me just use this. Okay. Uh, let me just this will be before delete. Okay. And after that, what I will do is I'll just call my delete ll function, delete ll function with what, with the address of the head. So this will also receive the address of my head. Okay. This will also receive the address of my head. Where is my insert? This will also receive my address of the head, and it will delete the entire linked list. So let me just see if my linked list is getting deleted or not. So what I will do is after delete. let me just check once more. Okay. Sure. I think it should work. No problem is there. Good. So let me just recompile it. No errors. So see what is happening. Before insert, the linked list was empty. After insert, a linked list was being created. It is just printing the same linked list before deleting. And after delete, what is happening? The entire linked list got deleted. Okay. Any doubts still here? Okay, I'm just showing. Sunfly is asking for the code, so I'm just showing the code. Okay, let me just make the code and the output side by side. Okay, this is the code. So, any doubts still here? We can move on to the next question at hand. Okay, by the way, this whole operation is taking how much complexity? The operation is taking the complexity of O of big O of n, because we are just iterating the whole linked list once. Okay, and is it taking any space complexity? No, it is not taking any space complexity. Space complexity is O of, sorry, O of n is the time complexity. O of n is the time complexity, because we are just iterating over the linked list once. Okay, and the space complexity is big O of one, the constant complexity. Why? Because we are not using any auxiliary space. This is the time complexity for the function, and this is the space complexity. Any doubt still here? So we'll move on to the next question at hand. Okay. So next question is also a simple one. What this question does asks is, if we know what we did till now, we created the structure, we inserted some elements in the structure at different places, we deleted the structure, elements of the structure, and now what we discussed now was the deleting the entire structure. Okay. Now, one more thing we need to know while discussing any structure is what is the length of the structure. What is the length of the structure? Like when we were discussing arrays, we also had a size function, and we could just loop through the entire array to find the size of the length of the array, and there is also a length of function in array. In case of strings, what we can do is to find the length of the string, we can consider strings as an array and just move till we encounter the null values there, and we can find the length. So, and why is length important? Length is a very important factor. Like in linked list, if we need to delete the nodes, it has a complexity O of n. Okay, and suppose if the length of the linked list is in itself 10 to the power 18, so we will not be able to apply this particular algorithm to delete the nodes. We will have to think of anything more. So anything different, unique. So that is why length of a structure is important. So how do we find the length of the structure? So what is the length of the structure? The number of nodes present in the linked list is the length of the structure. Okay. So what we will do is we already know how to traverse from the start to the end of a linked list. We already know this. What we need to do is we just need to start with the head and move on till we encounter the null value. Okay, and what we can do here is we can just start with a counter of 0 and just increment it by 1 until and unless we reach the null a node that is pointing to null. So this will mean that we have reached the end of the linked list. So that is why in this fashion, the value that will be stored in the counter C will be the length of our linked list. linked list. Why? Because what I'm doing is I'm counting every node until and unless we are reaching a particular node that is pointing to null. So we just have to make one small change to our code to count the length, to find the length of the linked list. Just small change, and we are already doing it while deleting the node while we are using this function, or if we are using this function, both are indirectly counting the length. If we can use just a counter here, we will find the uh, length of the linked list. But for simplicity, I'll just create another function to find the length of the linked list. So now let us find the length of the linked list. So let me implement it in a recursive manner now. What I will do is it will be returning some length. So let me make it as a returnable with find length. Okay, what will it be receiving? It will be receiving the head of my linked list. Okay, it will be receiving the head of my pointer to the head of my linked list. Now what I need to do is, until and unless the head is pointing to null, that means this is the last node. If my head is pointing to the uh, null, this means that this is the last node. And this case, what you return is, not if it is not a particular node, what I need return is, it is not a node, that is by return value of 0. Now this happens to be our base case. Now if it is not the it is not, if head is not pointing to the null value, that means this is not the last node. And if it is not the last node, what we need to do is we just need to count it as one. So what I will do is I'll just write return. What you should return is, you should just return one plus, because this is one of the nodes that needs to be counted. And again recursively call the same function, find node, find length function, with what, with the next node of the linked list. And the next node of the linked list will be the node that is pointed to by the head. So this is the node that is pointed to by my head. So this recursive definition does what, this counts the length of the entire uh, linked list. What it is doing is, it will have a base case when the head is pointed to null, that is if the node is the last node. Okay, the node after the last node. Okay, so in that case, what it will do, it will return 0. Otherwise it will what it will do is, it will just go on adding 1 to the value that is returned by the count of whom, of the smaller linked list. Which, what is the smaller linked list? The linked list starting from the eliminating this particular node, and the linked list after that. Okay, so I'm just using a recursive definition to find the length of the uh, this particular thing. Okay, so let me just find the length. So for this purpose, what I will do is, I'll just remove the delete part. I do not need delete ll here. Why it is not commenting? Okay, I do not also need this particular. Acha, and I also do not need this particular, like, for now. Okay. So what I will do instead is, I'll just call my uh, int length. Okay, let me just write directly. What I'll do is, I'll just write see out. What to see out? You just have to see out as length of link list. Okay, and the length of the linked list will be returned by the function named find length. And what we have to supply to find length function, we have to supply the head of the current linked list. Okay, so I guess this should work. Okay, so let me just call it. Let me just recompile my code. No errors are there, so we will move forward with. एक मिनट, just make small so that it ends up in the next line. Okay, what is happening now? Before, this is the insert operation that we have already discussed before. Now what is happening is it is counting the length of the link, that is 6. Let me just check it manually. 1, 2, 3, 4, 5, 6. So I guess nobody should have a doubt till here. How do we find the length of a linked list? What we are doing is I am just calling a recursive function. Okay, I'm just, if recursion is clear for you all, what I'm just doing here is I am just as this is what I'm doing is this is my linked list. This is my linked list. What I'm doing is this is my head. What I'm doing is whenever you are at a particular, if whenever you are at a node, what you do, you just count it as one, and then find the length of the smaller linked list. Linked list that is point whose head is the heads next. Okay, so what it will do is it will just one plus this link. Now this, instead what does it, it does one plus this particular link. This, what does it, it does one plus this particular link, and this particular link is null. And our base case is whenever head becomes null, you return 0. So what this will return is this will return 0. So this gets evaluated and this returns 1 plus 1. Then this gets evaluated, this returns 1 plus 2, and this gets evaluated and we get the final answer as 3. Okay, so this is what I am using here. Okay, you can just, I'm just making this is what the recursive definition that I'm using. Any doubts still here? Okay, where was the print length function? It was here. Okay, so see, and if anybody has any doubt till here, you can just okay. So we'll move forward with the next problem in hand. Okay, let me. So this was some of the basic problems that we get. Okay, now let's suppose if you can iterate to the end of the array, some questions can be asked as ki find the uh, nth node of the linked list. The nth node is find the fifth node of the linked list. What you have to do is you have to just iterate till the fifth node. So you just have to maintain the counter, and if at any given length the counter returns key count is 5, you have to just print the value there. Okay, so some of the functions are like that. So then there is something known as nth node from the end. Okay, so I'm not discussing those simple problems now. Okay, so let's suppose now so okay, one of the important problems can be how to reverse a linked list. Okay, so let me discuss that problem first. Some of the problems are there that are good problems on linked list, but we will discuss them after we have discussed some concepts like hashing and all. Okay, some of the questions need some further discussion on some small topics like hashing and some more STLs like ordered map, unordered map, etc., that are used to basically do perform hashing. Okay, so we will discuss some problems are also left in arrays, important problems. There are also some problems. We will discuss them after we have discussed some of the core concepts. So for the current discussion, let us look at one of the important question that is known as how to reverse a linked list. Okay, what is the funda I'm interested here is if I'm talking about reversing a linked list. So the funda that I am interested is, suppose my linked list is currently storing the values 1, 2, 3, 4, and 5. What I am interested in, the output of the function should be 5, 4, 3, 2, 1. Okay, and why is this an important question? Because we are using a single linked list. If we are using a single linked list and the links are in this fashion only. Links are in this fashion. So what is happening is, with there is no way possible to iterate back. There is no possible way to iterate back, because only one possible link is there in single linked list. That's why this becomes an important question. So what are algorithms can you all think of to do this? Okay, so one of the things that I can think of here is, if what I will do is, I'll iterate the linked list. I'll iterate the linked list one by one, and I'll use some sort of a stack, because I know what happens in stack is, in first whatever gets in first is comes out the last. So what happens is, if I have an array 1 2 3, and I want to push it into a stack, what will happen is the stack will look something like this. And when I will perform the pop operation on the stack, what will happen is the stack will come out like this: 3 2 and 1. Any doubts still here? What I'm doing is, I'm just pushing the array into a stack, from starting from the first element to the last element. So what will happen is, if I am using a stack, what is the property of stack? The stack is, okay, whatever element that gets in the first exists out the last, or whatever gets in the last exists out the first. So it follows something known as last in first out principle. So 3 gets in the stack at the last. So what will happen is, while popping out, 3 will pop out the first. So what will happen is, the while popping out, I will get a reversed array sort of a thing. So what we can do here is, we can just iterate the array in the iterate the linked list in the forward direction, keep on pushing the values of this thing, every particular node, into a stack after each operation. And at the end of the traversal of the linked list, what I will do is, I'll just perform multiple pops from the stack until and unless the stack gets empty. So what will happen is, the linked list will get reversed. But I do not have to do only this thing. Okay, we will also have to change the links between the particular operations. Okay, what will we do in every operation is, we will perform is the at 2, what is there, 1 ka link is with 2. So what should happen is, 2 ka link should become 1. So this should happen. So at any place, what we will do is, we will just get one temporary array, a temporary node. What we will do is, we will store the value of 1 here. I'll link 1 to this, then I'll link 2 to 1. Then what I will do is, I'll just link temp to 2. This is what the funda I needed to perform. Okay, I just have to perform a swapping kind of a thing. Any doubts still here? Whatever we have discussed, using link, yes, stack using linked list concept only. Okay, so we will just code this part now. Okay, so let me just create another function to reverse the linked list in this particular code only. Okay, so what I'll do is, what I will do is create I'll just create one function to reverse the linked list, and this linked list will receive what? It will receive, as I have to iterate the linked list, it will receive the address of the head. So inside this, what I will do is I'll just first of all I need to create one stack in which I will push all the nodes. So I'll use this stack STL to create. I'll discuss this thing in while I'm discussing stacks later in this course. So the stack will be of type what? This will be of type node, just as in case of vectors that we have discussed, vector, type int, and the variable name. So there what I will do is I'll just create a stack of node type to store all the node values. Okay, and this will store this. Let's name it as S for the time being. Okay, now what we will do is I'll just create one temporary node. Okay, I'll just create one temporary node and make the temporary node point to my head. Temporary node equal to my head, as we have done in the deleting the node. What I need to do next is I need to iterate to the end of the uh, array, end of the linked list. So if I have to iterate till the end of the linked list, what I have to do, I have to iterate until and unless my temp starts pointing to starts pointing to the what? Until unless it starts pointing to null. Because if any, what is temp storing? Temp will store the current node. And if my current node is pointing to null, that means that current node is the last node. Okay, that's why I'm using this particular condition here. So this is just checking whether my temp is the last node or not. This particular line is just checking whether my temp is storing last node or any other node. Okay, so here what I will do is I just need to do one thing. If it is any node but the last node, what I have to do, I'll just have to push the values inside one stack. I'll just push the values inside one stack. And the next thing that I will do is I'll just iterate to the next element. So what will be the next element? The next element will be, next node will be uh, temp ka next. This will be the next element, and because our condition checking variable is temp only, so I'll store this value in temp. What is temp now? Temp is now the second node, until and unless this whole process gets exhausted. And when it will get exhausted, when the temp will be the last node. Okay, so the stack S now has all the elements. Now the stack has all the values, all the data values, all the nodes. Okay, so what I will do now is at the end of this, and where is temp now? Temp is at the end of the original linked list now. And in while reversing, what will happen? What will, well, if 1 2 3 4 5 was my initial if 1 2 3 4 5 was my initial linked list, so where was head? Head was before, head was pointing to 1. But if I need to reverse this, what I need to do is I just need to make the head point to what? Point to the end of the original linked list. And end of the original linked list is stored at which, at what, in which variable? At temp, because the loop get exhausted only when it reaches the last node. So currently temp is storing the last node. Okay, so what will happen now is, what should I do now is I will just make the last node as the head node. I'll just make last node, make head point to the last node, and the last node is pointed to by temp now. So that this thing only I'm doing here. Now what I have to do now is I just have to make uh, reverse the linked list. What I will now do is I'll just pop out every other element, every node from the stack. And following the property of stack, what will happen is the popping will take place already in the reversed fashion. So what I will do now is I'll just, temp is my head now. So what I will do is I'll just keep on adding new nodes in its next. Okay, and my new linked list will be created. So what will happen is I'll just iterate it until and unless I'll just use one function of stack only until and unless my stack is empty. Until and unless my stack is empty, what I will do is I'll iterate in the entire stack, and what I have to do here is I just have to make my temp can next. What I have to make is I just have to make my temp can next, store the popped out value from the stack. What I will do is I'll just use stack dot pop here. Okay. Sorry. What I will do is the toppest value is stored is gotten by the top function. Okay, this gets the value that is the node that is at the top of the stack. So the next stores is the top the last element in the stack. Now what I have to do is I just have to delete that node from the stack. So what I will do is I'll just call pop function, and what will pop do? Pop will just delete the pop out the element from the stack. So now what I need to do is I just need to iterate further. So for iterating further, what I will do is I'll just make temp point to temp ka next. And we will do that by using this particular thing. I'll make temp point to temp ka next. And I guess at the end of this thing, the function gets ended. Okay. Again, let me just iterate over what I have done here. I am using one stack, okay, of to store node type values. Then I am creating one temporary node and making the temporary node point to the value that is pointed to by head. Now what I am doing is I am iterating till the end of the linked list and node of the linked list. And while I'm encountering any node, what I am doing is I'm just pushing that particular node. Okay, I have to push that node, not rest of push temp. So I'm pushing that particular node in this stack and just iterating forward. And for iterating forward, I'm doing I'm just storing temp next in temp. Now what I have to do is currently if this while loop gets exhausted, it will get exhausted, and the value that is stored at temp will be the value of the last node. So what I'm doing is I'm just making head point to the temp, and why I'm doing is just to make the head point to the last node. Now what I'm doing is until unless my stack gets empty, I am just making temp ka next equals to the element of the stack. Elements popped out from the stack and iterating it further until and unless my stack gets empty again. Okay, and at the end, what I need to do is at the end, the last node always points to the null. So at the end, what I will do is I'll make the last node of temp now point to null, and in this fashion, my this thing got executed. The linked list got reversed, and as I'm dealing with pointers, what will happening is the head is now uh, pointing to the end of the uh, linked list of the original linked list. So this is happening, something like this is happening. So let me just use this function. Let me use this function. I'll not call length here. Well, कोई problem भी नहीं है length calling. Okay, so what I will do is I'll just call my reversed linked list problem. After reverse and before receiving, I have to just call my reverse. What's the function name? It was reverse ln. It was reverse ln. It meets the address of my head. It meets the address of my head, and I think it is returning void only. Okay. So nothing. So after this operation, what will happen? My linked list will get reversed. So let me just call this function now. See what is happening. Original linked list was 59, 32, 55, 73, 65, 23, and the end node was pointing to nothing, null. What happened after reversing? After reversing, what happened was the entire linked list got reversed. The first node has become 23, and now 59 is pointing to nothing. Okay. Any doubts still here? Line 13. Okay. Let me just go back. What is line 13? Okay. Okay, Santhala, this is the thing. Okay, while using vectors, what I have to, how do we use vector? So we use the word vector. Then what we do, we use the data type of the vector, of the data type that the vector will store. And what we do now is we name that vector, like say a. This is how we were creating the vector. So this is in the same fashion we create other STLs too. So stack is a STL in C++. So what I'm doing here is I'm calling this stack as I was calling vector. In the angular brackets, I am giving the data type that this stack needs to save, and the data type that it needs to save is my custom data type, and the custom data type is nothing but node. Okay, that's why I have given him that it will store node type data. Okay, and then I have mentioned the name of my stack, that is S. Any doubts still here in the reverse function? There are other techniques too, like if I'm using stack, and you already know that recursion also uses stack by default. Okay, so you can also directly use recursion, because and then what I am doing is I am just calling the whatever operations that I perform on linked list. What I do, I perform that operation on one of the nodes and perform the same operation on the other nodes. So what I can do is I can just say ki I am performing the operation on a bigger linked list. Okay, and the base case will be perform the operation on one of the nodes of that linked list. Any operation that we are performing on linked list using any loops or iterations, we can also do that using recursion. Okay, using the principle that every node starting from the second node, it's again a linked list in itself. So any operation that can be performed on the main linked list can also be performed on the smaller linked lists. Any doubts still here? So let me check any other problem or the linked list. So as we can already see that all the questions on linked list, okay, do what? Need only a form knowledge of, if you are using pointers to directly play with the address. So what we know, we must know the form knowledge. We must have a form sound knowledge of pointers to deal with addresses. Otherwise, the whole gameplay here is using the links, using the next operator properly. Okay, and iterating the linked list, all the things can be solved using, if you are iterating the linked list properly and changing the links uh, properly. So the only gameplay in linked list is the play of changing the links properly, and nothing more. So whatever question you have to deal with, we'll use one of these concepts only. What you have to do is you just draw the linked list in your pen paper. Then what you do, you just take one temporary node and just see how can you change the links. Okay, using the temporary node, and one of the process you will get by which changing the links will solve your problem. So that's only you have to do. You just have to change links properly and your problem will be solved. Okay, so I think no problems are here. You can just solve any question. Okay, any while attempting any question, Just think, any question in linked list just is just a gameplay of the links, nothing more. You just have to play with these two lines properly. Okay, you just have to play with these two lines properly, and your work will be done. Okay, so now, and any problem can also be solved using recursion, because the if I can perform an operation on the linked list, say on linked list is 1 2 3 4, if I can perform any operation on this linked list, what I can do is, after removing one, what is the next linked list? 2 3 4 is also a linked list in itself. So I can also perform that operation on that thing. And we already know this is a basic funda of recursion. If you can divide sub a main problem into similar sub problems, then recursion can be applied. So any problem on linked list can be solved using, variety of problems on linked list that can be solved using iteration can also be solved using recursion. And if you have a firm grip over recursion like we used here, okay, that solves a problem. What I used here, I just used a simple concept that current length will be 1 added with the length of the entire linked list ahead. So I just use that concept here. Okay, so you can use the recursion to ease your problems. And when you're using recursion, just keep in mind, if you can think of recursive solutions, then that will be helpful while dealing with DP problems. Okay, so we will end the session today here itself. In case of any doubts, any feedback, mention it them in the comment section. And tomorrow we'll start off with discussing stacks and queues. Okay, what are stacks, what are queues? I have just given a glimpse of it here, so that after completing stacks and queues, I'll also discuss hashing if time permits tomorrow. Otherwise, day after tomorrow we'll discuss hashing, and then again we will move back to solving some important questions in linked list and and arrays. Okay, so I guess if you all have no problem, then we can end the session here. Okay, let me just share the address attendance link. Any feedback, guys, from your side? Assignments will be given and after some sessions. To master CPP for the term, I don't think it will take much time. You can give your 1 week or 2 week time properly, and you will get a firm knowledge of C++ to go ahead with your problems. Okay. And in the course of learning your data structures, solving your CP problems, you will also get some newer ideas about C++. Just one trick that I use is I do not go into studying any particular programming language in depth first. What I do is I just learn it for some time, get the basics of it right correct in my head, and then I start solving questions. So while solving question, I what I do is I whatever concept that is lacking, again I go and revise it or learn it. Okay, so you can also follow this thing. So in this fashion, it will not take much time. It will just take a week or two hardly to master CPP. Guys, about the test links and all, you will be briefed by the team. Okay. So guys, have a great day ahead. Okay. Good night. Great learning session. Or any feedbacks, then you can post it in the comment section. Otherwise, we are ending the session here. See you all tomorrow.